Hey guys, welcome to day 13 of programming every single day. Today it's gonna be relatively simple. Um, um, I found this course Gut.dev. Probably you guys have heard of it from like the Primeagen and stuff, but I haven't paid for them yet. But I've been trying to review certain concepts that the way I kind of like to do learn languages is like figure it out myself originally, like reading the docs, do a few leak code problems, or I did Avnet Code for a little bit, and then kind of explore the language a little bit, and then for certain topics that I'm not really good with, for example, struct. I'm gonna probably do just structs for today, because I don't have like a good struct foundation in any other language, even with C style languages. Like I haven't really used them like that well, so my understanding of them it's pretty limited, especially since I come from like an object oriented background ish. I mean, if you guys can call Python, Python is object oriented, but it's there's it's pretty like if you use the language, it's not very. It doesn't really listen to the principles of it. If you guys use Python, you would understand, but structs and interfaces. Maybe in TypeScript you would use like interfaces, but yeah, I'm not very good with like groups data like that. Other than like an OOP style, probably more like Python style, perhaps. But regardless, I just went through it just to see if, like, I like to see other people's explanations of how Go explained. There's some things I picked up that I never really realized. Like really small things, for example, like function signatures, like the last parameter per se, whatever that type is, could be the type, kind of transfer overs the type to the other previous ones. If I can show you an example here, like I can ignore this, and this last one would, if this declared as an int, this would be also a int as well, which is pretty cool. There's some like small things I like to be re-explained. So, and boot.dev seems like a good place to just try, but I don't want to really pay for it. Don't really have the money for that. I don't know. If you guys do, you guys think this is worth it? It's like $30 a month or like $50 a month. Um, I don't know. It's like I feel like the content itself is what's more important, and it's free for that. So I like that. It doesn't like guarantee. It's the only thing that you really paying for is like the gamification of it. Regardless, I just want to probably get through the structs today, see someone else's explanation of structs. Reason I'm doing this is I want to really brush up my Go. My Go is still very like beginner level and surface level. I have written like some like LeetCode style questions for it, but they're not very. I still want the fundamentals, straight and kind of flattened out and pretty comfortable, so I could start building some web dev projects. I still need to pick up on that soon. I'll probably have a project by maybe next week Friday. I just wanted to brush up on my fundamentals first. So let's do that. Probably what I'm gonna do is probably copy the file and see if I got it right. For maybe stuff like this. This is not that hard. I think this is just to demonstrate what I'm gonna do. I'll do it here. Cd learn. I'll make directory go. Cd go. Let's do main.go. And then main.go. Oops. Test.go. Yeah, I'm gonna just try it. I forget the environment that I need to set up. I think I have to do like a Go build or something. Oh, wait, it's the wrong file. Yeah. And then what should I do? So how would this? I feel like the environment is not correctly. I wouldn't be able to copy it exactly. If it was that easy, then you know it would have. Why would people pay? Let's see. What do they want me to? Can I even run anything? Well, let me see if it. Um. What does the main test code do? Type car struct. All cars have a brand model, doors. Okay, so we have phone number. This is an integer. And then, oh, it's int. And message is string. Yeah. I'm curious how this would work. Like, how should I set this up? I gotta look at my. I forget how to run GitHub. Not the Git. Run Grow projects. I think I have to run like a Go mod or something. Set up a Go project. Yeah, I do that. Okay, so it's go mod init. Oh. Okay, go mod init. I don't know. Learn go mod tidy. And then could I just run the go run main? Cannot run. Oh, it has to be a main file, I think. I have to set up the whole thing. I see. Oh, then. I don't know. I have no idea how to connect the two because I'm still learning this stuff. But this is straightforward. We'll move on to the next one. I just essentially just kind of do what I do with the Haskell stuff, which is kind of copy paste, learn, not copy paste, kind of copy and try to do the assignment here. Or maybe I can ask ChatGPT. Let's ask ChatGPT here. Yeah. I have this Go file. I have this main Go dot main test.go file. And then how does the advent of code have it? Oh, I need to, and have a main.go file, and would like to test the stuff in my main Go file. Okay. So I just have this here. Oh, you used test. Wow, that's nice. Oh wow, okay. This is kind of, I'm learning how to use test here. Go test. That's V. Oh, nice. This is really nice. Okay, this is good. We pass. So you could just run the Go file. Do I need this here? Or do I? Do I need this here? Or does it know how to look it up? Wow, okay. I think that works. Does that... Wait, let's see if... Let's see if I fail it. Nice. Okay, this is I can do this now. I can work with this. Yeah, it's gonna be tedious to go back and forth, but it's okay. That's what I get for not paying, you know. So nested structs, type, car struct. The fields of a struct can be accessed using the dot operator. Let's copy this. And let's copy this. We've been sending texts that are missing critical bits of information. Before we send text messages in text.io, we need to make sure that they require qualifiers of non-zero values. So these structs can be made up with other structs. Notice that user struct is a nested struct with a message to send struct. Complete the send message function if it can return true if the sender and recipient fields can contain a name and number if any of the So complete the can send message is to return true only if the sender and recipient contain a name and number. Okay. So essentially, if the user m to send dot Is this not if m to send dot, what is it, sender dot if it should return true if sender and, so I'm gonna make this, so let's start with sender first. If the sender has a name, then return false. We'll say or m2 to send dot recipient dot name. Okay, is there such thing as truthy and truthy checks go? So I can't do that. I have to say equals like that. Would that be a valid? And we could do it says return true if the sender and receiver, if any of the default values are present, return false. Okay, so I gotta do this for a recipient as well. Oh, not recipient. The number. So like 0. Is that what is the default value of? Does that work? Okay. Let's actually start a TMUX session. And go. Alright, go test. Verbose. Do I actually pass? What if I just always return true? Just to make sure this is running correctly. Fire. File. Passed. So yeah. Yeah. Next one. Anonymous structs, just like a normal struct, but it's defined without a name. So yeah, you can just define it. Nice. Just instantiate Name structs. Name structs make it easy to understand your code, and they have nice side effects of being reusable. Sometimes use anonymous structs when I know I won't ever need to use that struct again. For example, sometimes I'll create one to shape some JSON data in HTTP handles. If a struct is only meant to be used once, then it makes sense to declare in such a way that the result won't be tempted to accidentally use against. You can read more about anonymous structs. Okay, cool. What do you guys think? Do you think it's worth it to pay for boot.dev? I mean, like, technically you can do 1 month free and then refund, but it's a bit scummy. But I don't know. As a student, I would love that, like, a little student discount if it's really worth it, right? Embedded structs. Let's run this here. Take this over here. That was test. Go is not an object-oriented language. However, embedded structs provide some kind of data only inherited that's going to be useful at times. Keep in mind, Go does not support classes or inheritance in the complete sense, but embedded structs are a way to alleviate and share fields between struct definitions. Type, yep. Car is embedded. Okay. Embedded versus, unlike nested structs and embedded structs, fields are accessed at the top level of the normal fields. Like nested structs, you assign promoted fields with the embedded struct in a composite literal. So yeah, like stuff like these, like little details that I wouldn't really pick up, like learning on my own. It's sometimes nice to kind of get an eye on. So I do like some of the courses, but I try to avoid being lenient. I'm trying to build more projects around that token. So let's try to understand this. This is instantiating a struct called the truck, which has a car struct as well, by initiating that. So like the nested structs, instead the nested equivalent of lanes.truck. Yep. Oh, so they inherit these attributes. So you could just go. Interesting. So that if this is embedded, you could go lanes.brand immediately. Okay. At textile, a user struct represents account holder and the sender is just a user with some additional sender specific data. A sender is a user that has a rate limit. A user struct represents a account holder, and a sender is just a user with some additional sender specific data. A sender is a user that has a rate limit field that tells us how many messages that are allowed to send. Fix the bug by embedding the proper struct in that order. So yeah, a user extends to a sender essentially. So I gotta fix. So right now, if I run this, what would happen? Go test. Yeah. Let's go back here. So what's the issue here? In the main Go file, right? I believe it's trying to use like this stuff like user.ratename, but you don't have that in user, so just embed it, right? Embed it as sender. How does that work? Oh, okay. There's more to that then. In the other. Is not how do you embed it? Should I put this above? With this fail? Oh, build failed. Okay. What is this error telling me? What is this telling me here? Undefined s.name, s.aim. Oh, this whole thing is not working. Am I missing something here? Oh, so you have to put it at the bottom. Yeah, exactly. Car is embedded to the definition. Truck also in addition contains all fields of the car struct. Okay, we did that. Unlike nested structs and embedded structs, fields are accessed at the top level numbers. Like nested structs, you assign the promoted fields with the embedded struct in a composite literal. As a sender, as a user that has that tells us how many messages they're allowed to send. Fix the bug by embedding the proper struct in that order. Oh, wait, is it the opposite? So should I embed user instead? Is that what we're saying? And then put, and like this, is this what they want? Yeah, perfect. So we're saying a sender is a user. Oh, yeah. And you embed it at that. Okay. Nice. Let's move on. Struct methods in Go. While Go is not object-oriented, it does support methods that can be defined on structs. Methods are functions that have a receiver. A receiver is a special parameter that syntactically goes before the name of the function. Area has a receiver of rect. I see. What does this R mean? A receiver is just a special kind of function parameter in the example above. The R is a parameter in R that can be easily just been rec or XYZ. By convention, Go will go with optim, the first letter of the struct's name. They will, as you learn, also define interfaces that our structs can implement. All right, let's grab these joints. I think here is we gotta make the method here, which is pretty nice. I don't get access to the solution, right? Crap. Trying to get the money out of me, man. But I don't know, it's too broke for this. So we'll make a, what do let's clean up the authentication logic. We store our user's authentication data inside an authentication info structure. We need a method that can take the data and return a basic authorization string. The format of the string should be create a method on the called get basic auth. All right, so it's gonna be func a basic a authentication, and is a get basic auth. Like that. That's how you build it. The return type, I believe, is string. They can take the data and return a basic authorization string. The format of the string can be authorization basic. Let's do that essentially, right? Hold on. SAIW. Okay. I wish there was a way to wrap the entire line on one, but you know, it's okay. fmt.sprint. I gotta import that. Import fmt sprint f, and we should do the a.username and a.password, and we would like to return this. Also, I think there's one more thing I need. Sprint. Oh yeah. Say value here. Or was a string, right? S. All right. Run this shape mine. Awesome. Pass. Nice. All right, memory layout in Go. Structs in memory. In Go, structs sit in memory in contiguous blocks with fields placed one after another as defined in the struct. For example, the struct Four bytes total. Field ordering matters. The ordering of fields in a struct can have a big impact on memory usage. This is the same struggle as above, but poorly designed. Wow. See, I would have never have known this, you know? The ordering of the memory matters. The reach 2 bytes num post. The order of field structs in a struct can have a big impact on memory usage. This is the same struct as above, but poorly designed. Huh. it looks like this in memory. So big to smallest. Notice that Go has aligned the fields, meaning that it has added some padding to make up for the size difference between the types. It's done this for execution speed, but can lead to increased memory usage. You should not stress about memory layout. However, it should have a specific reason to be concerned about memory. You have a specific aligning fields by size, large or small, can help. You can use the reflect parts to debug the memory layout of a struct. Real nice. Structs in memory, like hundreds of thousands in a list. When I reordered the structs in the usage of dropped over 2 gigabytes. It was a huge performance one. Over engineering boss as added again. He heard about the memory layout and wants to squeeze every last bit of our structs. Run the test to see the current status and then update the structs to minimize memory usage. Alright. Main go, we could go here and go like this. So let's see what it looks like right now. I see. I assume this is gonna be bigger or something. Like this. Integers are bigger, I assume. So can we do that? Nice. That's really cool. Never knew that. Wording of structs matter. Are used in Go as unary values. An anonymous empty struct typed. Named struct type. Cool thing about the empty structs is that they're the smallest possible type in Go. They take up 0 bytes of memory. Wow. Each byte is like 8 bits. $16 bits, 64 bits. Yep. Takes up a lot of space. Alright, let's do these last 2 ones and then we'll continue tomorrow. This was the main, so. Alright, so I gotta implement what here? Update users. We need to differentiate between standard and premium users. When a new user is created, they need a new membership. They need a membership type, and that type will determine the message character. Create a new struct. Membership, it should have a type string field. And I forget, is types uppercase? Not sure. Well, in this case, I assume it does or something. I don't know. And a message character. Let's do that. we'll create some users. We'll create another type, membership, and it's a struct. And it has a type, what kind of membership. It's a string. And the message character limit, and this is a integer. Very nice. To embed, update user to embed membership. Okay. So this also, every user has a membership. And complete the new user. You should return a new user with all the fields. Yep. Okay. So let's do return user. Start with the membership. Membership. Here membership is the membership type. I'm not sure what this is. How do you I forget. What do you do to add stuff? How do you instantiate again? Okay, JavaScript. I probably should, definitely do this. So we have membership. It has a type of membership type, and has message character limit of if the user is a premier. Okay. So if membership type equals premium, character or character limit is 1,000. By default, it should be I think by default it should be 100. Character limit. More. We have a membership type and a name. So this should be name. Missing a colon before the new line. Okay. Where? Here? Mixture of field val. Oh, I see. I can say membership. Look at that. There you go. So those are the fields, those are the conditions, and yeah. Awesome. Let's do another one. Mm, um, I gotta make another struct or something. Create a send message method for the user struct. Interesting how I can define the methods above it, but okay. So function of type user, and it's called send. What is the return type? Message and a string as its input. Hold on. What does the syntax look like again? When I create like kind of methods for the struct, how is it supposed to look? If this is a normal function, I should be able to take a normal parameters, right? Message as string and message length as int. And what do I return? Boolean. So what am I saying? If the message length is within the user's character limit, return the original message and true. Okay, so string and true. So string so is that how this works? So if the message length is within the user's character limit, return the original message. Otherwise, return an empty string and false. So if return an empty string and false. This is the default. If the message length is within the user's character limit, if u dot message character limit, less than or equal to, limit is within. So I guess, can you say less than equal to, and we say length of message. Whoa. I'll return the message and true. is just the accept. Yeah. Very nice. Okay. I'm getting it. So we're making little, like, we're making valid stuff here. Like, we're making use of the structs. I'm getting a better understanding of it. I never really see, like, stuff like the memory layout, like small details. I would never know from, like, someone else's explanation of things. And then, yeah, it helps with a lot of stuff here. So yeah, tomorrow we'll do interfaces tomorrow, and I'll do some of these as well. Like, I already know how they work, but it's something like I need like another look at, because it's sometimes a little confusing with like slices and strings. These are another one to get good at as well. That's why I'm gonna go through the entire thing. It's just really nice to get another perspective of Go's language, and then boom, project soon. But that's it for today. Thanks for watching. I'll see you tomorrow.